Hi guys, it's Mrs. Cerami. We're finishing 9.4 today. Yesterday we did arithmetic sequence. Today we're going to be talking about a geometric sequence. Geometric sequence is when you have a pattern formed when you're multiplying the same number times the previous number to get the next one. So for example, and I'll just do a general example here. Let's say we had 2 and then 6 and then 18. So we're multiplying each of the previous terms by 3. We can do one more, 54. So geometric means you're multiplying the same number. The number that you're multiplying by, this is called the common ratio. Okay, so that's the vocab for common ratio. And the variable we use for that is a lowercase r. So we have two different formulas that we create for geometric, just like arithmetic. Explicit is where you take your first term, a sub 1, which we talked about yesterday, and you're going to multiply the first term times the common ratio. Raised, this is an exponent here, raised to n minus 1. What is n? Well, if you're looking for the 10th term, then n would be 10 here, a sub 10, and you would do r to the 9th power. Recursive is when you this is an example of recursive, is when you multiply the previous number by the common ratio to get the next one. So if you know the third one, you can get the fourth one by multiplying by 3. So it's a sub n, the term you're looking for, equals the term before it times r. Again, these restrictions I'm not going to worry about you writing out for me. That we're just really going to worry about the two formulas. So we're just going to talk quickly about the difference between arithmetic and geometric. The question is, how do we go from 8 to 22? We're not multiplying. We're adding 14. It looks like we're adding 14 here as well. So this is going to be an arithmetic. And how do we find the next term? Just add 14 again, and we get 64. Here we are multiplying by 5, but if you notice, the signs are alternating. When you alternate signs, you're multiplying by a negative. So we're multiplying by negative 5. And the type of sequence here, because we're multiplying, is going to be a geometric here. And if we multiply negative 750, we'll get 3,750 here. The 1/3, again, we are to get from 1/3 to 1, you can add 2/3, but it doesn't follow suit. So we can multiply by 3. It's easier really to look in the middle. And you can see 1 times 3 is 3, 3 times 3 is 9. So if we continue, the next term here would be 243, and because we're multiplying, it's geometric. And then here we are subtracting 6. So the next term would be 2, which is arithmetic. So arithmetic is adding or subtracting, because really you're adding a negative 6. All right, now that we know the difference between the two, write the first 6 terms of each arithmetic sequence. So we know a sub 1 is 3. So first 6 terms, so we want a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6. So this is really my a sub n. Okay, the last term we're looking for is our a sub n. So common ratio, we know that we're multiplying by 2. So this is going to give us 6, 12, 24, 48, and 96. So there we have it. If you want to try for the next one, you could pause here, or we can just go through it together. So again, we want the first 6 terms. So a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6. So our first term is 2,000. We're going to multiply by negative a half. So that means I know each one is going to alternate to positive and negative. So half of that's 1,000, which will give us negative 1,000, 500, negative 250, 125, and then 62, negative 62.5. All right, now this is what you'll see on my math lab. Again, you're going to have 2 problems where they're asking you 4 different pieces of information on each. So they're going to ask for the common ratio, the 10th term, a recursive rule, an explicit rule as well for this. Now, so the common ratio, again, so A. Common ratio is what you're multiplying by. So we're multiplying by 3. So our common ratio there is 3, which is going to be our R. The 10th term, again, just like we did for the arithmetic, I would hold off on that. You could list it, but I kind of like doing the explicit rule and just putting it in. So C is going to be the recursive rule. So the recursive rule is a sub n, general formula, is where you're taking the previous term, so a sub n minus 1 times r. Okay, so again, the general form would be a sub n. We don't know what the a sub n minus 1 is, and then we know our r is going to be 3. So you can even put a 3 in front of there. And for D, we want a general explicit rule. So explicit rule is we want a sub n. We start with the first term just like the arithmetic, and we're multiplying that times r to the n minus 1. So the only thing that's constant here is the r. So we have, and they're a sub 1. We know our first term is going to be 2. So we're going to do 2 times 3 to the n minus 1. This is not the same thing as 6 to the n minus 1. Order of operations is you exponent first and then multiply. These are the general forms. So if I want the 10th value, I would use, that one would be too complicated because we don't know the 9th one. So I would definitely use the explicit, just like we did with the arithmetic. So what we're going to do here is we're going to do 2 times 3 to the 9th power, because n minus 1. And when you do 2 to the 9th power, we're going to get, and you do need a calculator for this, 39,366. So no, I didn't do that in my head. I do have that written down from the calculator. So again, this is not so great to use for the term, and this is what I use to find the 10th term. What I would do is I would pause the next one, see if you could do it on your own, and then check your work. And again, these are the two, this is the type of problems you're going to have for homework. So again, we want to find A, the common ratio, which we know is our R. So we keep having stable ones here, but so we're multiplying by 1, but the signs are alternating, so it's -1. And then we know we want the 8th term here. So you could find patterns through this. We know that each even one is -1. So 8 is even, it's going to be -1, but just to prove it, we'll go through the work. And the explicit rule, so a sub n equals a sub 1. And again, we're starting with the a sub 1 here. So you need to know the formula, times r to the n minus 1. So when you plug this in here, we are going to have a sub n equaling a sub 1, which is 1, times r, which is -1 to the n minus 1. So we have a sub n equaling -1 to the n minus 1. We don't need the 1 over there. And then D, we want the explicit rule. Oh, this was explicit actually. This is explicit. We want the recursive. So recursive is where you're using the prior term. So you're going to use the a to the n minus 1. So it's a to the n minus 1. So you're taking the previous term and just multiplying it times r. So again, we don't know our a sub n. We don't know our a to the n minus 1. But we know that we're multiplying by -1. So you could really write this as a sub n equals negative a to the sub n minus 1. And then what I would do is, again, if you put it in the explicit right here, we want the 8th term. So you're really doing, so for this one right here, you're doing the formula -1 to the n minus 1. And 8th term is really -1 to the 7th power, which gives you -1. So that proves that answer. All right, so you just finished the last section. We're going to have a test on chapter 9. An outline is forthcoming. Have a good day, guys.